Hello, hi to everyone. Today we are going to solve one problem which is related to DFT problem. Okay, this problem is very important from the exam point of view. Okay, so usually uh, we can solve the DFT problem in the three ways. Okay, one is the direct computation method. What is that direct computation method? Direct computation method means you can solve the problem by applying the equation. So today we are going to solve that problem only, that is direct computation method. Okay, the remaining two methods are, one is matrix based method. Okay, another method is butterfly method. These two methods are very important from the exam point of view. Usually they will ask the question based on direct computation method, and another method is butterfly method. So they won't ask a matrix based method. So sometime they will ask the question like this: solve DFT problem. That's all. So that time you can use matrix method. That method is very easy to solve the DFT. So we will discuss in the upcoming videos other two methods. Today we will discuss the direct computation method. Okay. So okay. See here, compute 4-point DFT and 8-point DFT. DFT means discrete Fourier transform. Okay. DFT of causal 3-sample sequence given by, what is meant by causal? So if the samples are if the samples are exist at the right hand side, so such samples we call as causal. Okay, so if the samples are exist at the RHS side, RHS side, right hand side. Okay, so such samples we call that one as what? Causal signal. So if the samples are exist at the both side, we call that one as anti-causal. I think you have studied all those things right already. So without wasting our time, we will go. We can solve. We will solve the problem. Okay. So sometime, so they will give the problem like a sample, right? Sample means, so x of n is equal to, okay. So those samples are lies between the two flower bracket, right? So 1 comma 2 comma 3 like this. So they will give directly. So no need to solve. Okay. Here they have given the functional method. Okay. So here sometimes they will give, instead of here they have given the number. So instead of giving the number here, sometimes they will give as a equation. So you have to apply the values of n, you have to solve the problem, you have to find out the samples. Okay, we will solve such problems in the upcoming videos. So okay, so here they have given the function x of n is equal to 1 by 3. That n is the discrete time, right? N is lies between, n is lie between 0 to 2, right? N is lies between 0 to 2, 0 otherwise. Okay, if it is less than 0, then the value is 0, or the magnitude of the signal is 0. If the sample is greater than 2, which means it is 3, 4, 5, so then the magnitude is 0, which means, So see here is 0, right? So this is 1 by 3, okay? 1, 2, right? So for 0 is 1 by 3, the magnitude, this is n, okay? So the x-axis is n, the y-axis is magnitude, or sometimes we can also call this one as amplitude, okay? So I know what is the, I think you know very well what is the difference between the amplitude and magnitude, right? Okay, we will discuss those things in the upcoming videos. Don't worry, right? Just see this problem, okay? So for 0, 1 by 3. For 1 also, 1, the magnitude is 1 by 3. 2 is also, the magnitude is 1 by 3. If it is 3 means the magnitude is 0, right? If it is 4 means the magnitude is 0. If it is minus 1 is magnitude is 0, and so on, okay? This is the graphical representation of this equation, this functional representation of problem, right? So now we'll solve the problem, okay? So that this is the DFT equation, you know very well, right? X of k is the DFT of x of n. This is the x of n, right? This is our x of n. This is our x of n, right? So here we have to find out the DFT of this x of n, okay? So summation n is equal to 0 to capital N minus 1. What is this n? N is the number of points, right? Number of points, you have to find out the DFT. Here they have given n, right? 4 point, this is the capital N, right? 8 point, this is the capital N. Here you have to find out the DFT of x of n for 4 point and 8 point. Today we will discuss only for 4 point. The 8 point, the similar way you have to solve the problem for 8 point also, okay? Just I will upload this notes, okay? Just check it out, okay? For I have solved the problem for 8 point also, okay? um, x of k is equal to summation n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n into kn. Here k and n, right? N is the discrete times samples, k is the frequency samples, right? K is vary from 0 to n minus 1, right? 0 to capital N minus 1. This is very, very important. And small n is also varies from 0 to n minus 1. Okay? 0 to n minus 1. N is the number of point. Okay? This is frequency domain. This is time domain samples. Okay? N is the number of points. Okay? DFT points. Okay? Usually we call this one as twiddle factor. How we will represent that twiddle factor? W, N, right? Superscript. This is subscript of N. Superscript of Kn. Right? Kn. So Wn, how we will find out, how we can represent W e to the power of minus j 2 pi. Okay, e to the power of, 1 second, I will erase this, minus j 2 pi to e to the power of minus j 2 pi. This capital N is will come here, and this small k and n appears here. Okay, so W is represented to the power of minus j 2 pi. Okay, so This is our DFT equation. Okay. So now here we are going to discuss 4-point DFT. Capital N is equal to 4. Okay. So x of k is equal to summation small n is equal to 0 to capital N minus 1 x of n e to the power of minus j 2 pi by n into kn. Right. So here our capital N is 4. So 4 minus 1 is 3. Right. N is equal to 0 to n minus 1. 1 by 3. Right. What is this x of n? X of n, x of here in the problem they have given 1 by 3, right, amplitude, right. So I have written here 1 by 3 e to the power of minus j 2 pi, capital N is 4 into kn, right. So now we have to apply, so this small n value, right. First we have to apply small n value, then we will apply the cap capital K value, okay, or small k value, okay. So we know very well after 2, right. So up to 2, this is equal symbol. These symbols are very very important during exam, okay. Just don't hurry to solve the problem. Read the problem 2 to 3 times and understand the problem, okay. And after understanding the problem, note down the given values, okay. Don't hurry up, because many of them solve the problem very urgent, then they won't see the problem what they have exactly given, right. They will note down they will note down the wrongly, then they will solve the problem, then the entire problem will be wrong. Say, so please read the problem carefully, okay. So here they have given the symbol equal. This is equal symbol, right. 0 is greater than equal to n and less than equal to 2. So n is lies between 0 to 2. It is equal, right. Okay. So for 0, 1, 2, the magnitude or the amplitude is 1 by 3. So if it is greater than 2 or less than 0, it is 0. So that's why I have written here. So instead of 3, I have written here 2. So if it is 3 means the magnitude is 0. So that's why I have written here as a 2. Okay. So after that, so first apply the value of n 0 to 2. So e to the power of 0. You know very well what is the general equation of exponential function, right? So e to the power of minus j theta, right? E to the power of minus e to the power of minus j theta, right? E to the power of minus j theta is equal to cos theta minus j sin theta. Okay. So by we are using this equation to solve this problem. This equation is very, very important. Please memorize this equation. Okay. So then here, so e to the power of minus j. So before applying this equation, just I am applying the value of n, okay. So here we have to substitute the value of n here, okay. So first we have to apply 0, right. E to the power of 0 means 1. We know very well e to the power of 0 value is 1. How we got this 1? So e to the power of 0 means cos 0 minus j sin 0, right, minus j sin 0. We know very well cos 0 value is 1 minus j sin 0 value is 0. So that's why I have written here is e to the power of 0 as a 1. So next, so we have to substitute the value of 1. So here I have taken this common value 1 by 3 outside, okay, here. Then e to the power of 0 is 1. So now e to the power of minus j. So this is 2 1s are 2, 2s are 4. e to the power of minus j pi by 2 into k. Here the value of n is 1, right? Here the value of n is 1. Okay. Now again we have to substitute the value of n is what? 2. So here if you are substituting the value of 2 is this 2 and this 2 is cancelled out. Then we will get e to the power of minus j pi k. So I have written that. Right? So you know very well this is a summation symbol. I don't want to discuss all those things. These are very simple, right? So if we are exploring this summation, right, summation equation, we will get like this, right? After each value we have to put this plus symbol, right? So first e to the power of 0 1, right, plus e to the power of minus j pi by 2k into 1 plus e to the power of minus j pi k. After substituting 2, we will get this one, right? I think you know very well, right? So after this, we have to describe this e to the power of minus j theta. You know very well, e to the power minus j theta is equal to cos theta minus j sin theta. Here the theta value is this one, right? Theta value is pi by 2 into k. So 1 plus e to the power minus j theta cos theta. Theta is pi by 2 k, right? This is a theta, okay? Minus j sin theta pi by 2k. Similarly, you have to describe this equation. So e to the power of minus j pi k, right? Cos theta. Cos theta. Theta value is pi k, right? Theta value is pi k. Don't consider this one, okay? Be careful while writing, okay? Minus j sin theta pi k. Okay. So after substituting that, now we are going to find out DFT value of x of n by substituting the value of k. The k value is vary from, as I said before, the k value is vary from 0 to n minus 1, right? So here the capital value of n is 4. So 4 minus 1 is 3. So the k value is, the k values are 0, 1, 2, 3. Okay. Now we have to substitute these values. Okay. Then we have to find out the DFT value of x of n. Right. First we have to substitute the value of k value as a 0 for this equation. For this equation, we have to substitute the value of k. Okay. So now we have to, first we have to substitute the k value 0. Okay. Apply k value x of 0 is equal to 1 by 3. So 1 plus, right. So cos 0, what is the value of cos 0? 1. Sin 0 is 0 minus j 0 plus cos 0 value is 1 minus j sin 0 value is 0. So 1 plus 1 plus 1, 3. So 1 by 3, right, into 3. We will get 3. So 3 get cancelled, right? 1 minus j 0. Here usually the x of k value should be complex value, right? So here this is a real part, this is our imaginary part. Usually we will represent the imaginary part. This is real, right? Always it should be integer, right? Integer or fractional numbers. Here or we can also call that one decimal number, right? This is an imaginary number. Here we have to represent the imaginary number using the letter J, right? So you know the value of J, right? What is the value of J? J is equal to square root of minus 1. This value is very important to solve some of the problems, okay? So usually the x of k value is complex number. That's why here we are representing 1 minus j 0, right? So here we have to convert. This is a polar form, rectangular format, right? This is a rectangular form. We can also call this one as complex number. What is this? This is a complex number. This is a rectangular format, right? So we have to convert this rectangular to polar, right? So I will make one video separately, right? How to find out the complex to polar format. Okay. So here I will tell orally. Okay. If you have calculator while solving the problems, especially DSP and signal system, please keep one calculator along. Without calculator you can't solve the problem. Make sure. Okay. So in your calculator it should be higher version of calculator. Okay. FX, I have FX991 MS. Okay. Switch on your calculator. Okay. Then beside that on button you can see that mode. Press that mode button. Then you can see COMP, comp and complex. So we need complex. Okay, complex mode. Press 2. Okay, press 2. Then the calculator change it to complex mode. Okay, then you have to press 1. So we are going to convert this complex number to polar format. Okay, so polar number. So press 1, then after minus, press 0, then after. So in the engineering button, ENG, right? Press that button, you will get I. Okay, I, that represents imaginary. Okay, that represents imaginary. It is a variable. Okay, press is equal to. Thereafter press shift button, then press plus symbol. You can see, you can that above that plus button you can see that R, phase angle of theta. R is a magnitude, angle theta. Theta is a phase. R we can also call this one angle, right? Press that shift, thereafter press plus button, then press is equal to. You will see the magnitude. So the magnitude is 1, right? So in order to see this phase angle, right, press shift, then press, one second, plus, one second, one second, I will repeat. Z 1 minus 0 I, right? So press shift and press is equal to button in order to see the phase angle. So the phase angle is 0. Okay, just try to solve this, okay, at your home. Otherwise I will make one video, then I will just watch that video. Okay, so similarly you have to solve for x of 1, right? So and x of 2, x of 3. Just I will explain x of 1. Okay, so here 1 by 3 is the common value. Put the value of k as a 1, where you have to put that k value is 1 here. After calculating the value of 0, you have to substitute the value of 1. So in this equation, so here also you have to put 1 here, here also, right? So here initially we have substitute the value of k as a 0. Now we have to substitute the value of k as 1. So thereafter you will get this equation, right? So you note the value of cos 90. Cos 90 is 0, right? Sin 90 is 1, right? So cos 180 is minus 1, right? So sin 180 is 0. Okay, this minus 1, right? This plus 1 will get cancelled out. So you can see this only minus j1, 1 by 3 minus j1. So by using calculator, just find out the um, polar format of this complex number 0 minus j1, right? You will get this one. Will also represent in radian by using pi value minus pi by 2. you know the value of 1 by 2, right? You know the value of 1 by 2 is 0.5 minus 0.5. So in order to represent in pi, I am converting like this. I am writing like this. Okay, you can also write, you can finalize your answer here, right? So you can also represent the value in this format. So you can also represent in this format. So while drawing the while drawing graph, so that time this type of format is very useful. Okay, so similarly calculate the value of k is equal to 2 and k is equal to 3. So finally you will get the 4-point DFT value of x of n. This is a magnitude, this is a phase or angle. So here we are representing the magnitude like this, right? Magnitude of x of k, you know very well what is the equation of magnitude of x of k and phase angle of x of k, right? So how will you find out the magnitude of x of k? How will you find out? So I have that equation with me. It is here, the magnitude of x of k, right? So the real part of square actually is square root of a squared, real part of xr, I mean x of k, this is x of k, r represent real, okay, j represent imaginary, right? So xr of square k plus x subscript j square of k, this is real part, I mean simply a square, this is real part plus this is imaginary part. Okay, so you have to take real part of x of k, right? And b is the imaginary part of x of k, right? This is a magnitude. In order to this is a in order to find out magnitude, you have to use this equation, square root of a square plus b square. In order to find out phase, tan inverse, imaginary part of x of k, real part of x of k. Okay. So this is your 4-point DFT of x of n. So this is the magnitude. So just I have taken this magnitude values. Okay. So this one is the phase angle values, right? That's all I have represented separately, the magnitude value and phase value. I think this video is very useful to understand the DFT problem. Thank you very much. Happy learning.